try nitrogen, phosphorus. Let's do chlorine first, then phosphorus. And just to have some, oh, we need to get over there. We need to get over there. Let's get to here. Forget chlorine. And we need to get into that. We have to get into that. And just to really make you guys have some fun, europium. Because how much fun can you have in one?
I was so ready, and then you just broke my heart.
By the way, we are going to be done with the electron configuration notes. This is it. Ryan, I don't even know what that means. What does that mean? Is that what that is? That? It's just like somebody to explain why that's okay. shall we? Okay, so nitrogen, 7 electrons. 1, 2, 3, 4, 5, 6, 7. Everyone hunky-dory. Awesome. Phosphorus, 15 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Arsenic, 33, I believe, yes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 30, 31, whoa, 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 32, and 33. Everyone hunky-dory so far? Just out of curiosity. How many valency electrons does nitrogen have? Thank you for saying that. Who said 3? Somebody said 3. Thank you for saying that. That is wrong, but thank you for saying that. How many valency electrons? 5. We'll come back to you here in a second because there's 6 other people that were thinking the same thing. Okay? How many valency electrons does phosphorus have? 5. How many valency electrons does arsenic have? 5. I know you do now, okay? What happened was, then initially, and 5 or 6 other people initially, looked at the highest orbital, right? These are all p orbitals, okay? But remember, energy, it's the highest energy level. So we're talking both the S's and the P's, the second energy level. For phosphorus, we're talking the third energy level. For arsenic, we're talking the fourth energy level. Clearly, they're all in group 5A, correct? I mean, up until about a day ago, you would have immediately said 5 because, oh, look, it's in group 5A. Well, this is why there's 5 valence electrons. And then finally, europium. How many electrons? About 4,286. It feels like 4,286. This will be the last time I ever have you do an element that I just wanted you to do it. Actually, there's 2 reasons. 1, I wanted you to do it, and 2, there's a learning piece that we have to go through over here. So I can't, honestly, I don't remember. It's like 50-something, isn't it? What is it? 63. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. So far, so good. Now, what did you do from here? Well, it depends on the periodic table you're referring to. Your periodic table, okay, when I say your periodic table, I'm speaking of this periodic table. I believe takes you immediately to the 4F. Is that correct? Okay, let's look. So we're here, right? We're at barium so far, 56. Okay? Your periodic table immediately takes you to lanthanum, into the 4Fs, right? If you were looking at this periodic table, which is what I have a tendency to do, you would find out that lanthanum actually is a 5D. And then we start the 4Fs. And so you might be saying, wait a minute, how is that possible? How can you have different periodic tables telling you different things? I don't see anyone using the actual periodic table that you'll have available on tests and quizzes, which I find kind of interesting. Oh, here we go. In which case you would have to go to lanthanum first also. That actually makes it more obviously a 5D. Would you go 5D first? Oh. Just out of curiosity, why not? Oh, you use this instead of the periodic table. Okay. Since there's really only one periodic table that's going to do this, I'm going to recommend not doing. That's the one you'll never have on a test or a quiz. Okay. This would actually be a 5D. So that's according to the one that's you're going to have available on a test or a quiz. According to that periodic table, this would be a 5D. It would be a 5D1. And then, what's that, 57, 58, 59, 60, 61, 62, 63. So what's the issue here? Why do different periodic tables tell you different things? We're going to find out the deeper that you go on a periodic table or in the periodic table, there's going to be some exceptions to these electron configurations. And that has to do, remember how crowded it was getting way up here? We had all those orbitals, and if you remember on that diagram on page 107, how the energy levels were really packed together fairly tightly. There's a lot of electrons in a lot of orbitals in a really small place. And we already talked about how they overlap a little bit. Okay? We're going to have some small exceptions. Here's the thing. I'm not going to have you memorize any of the exceptions. I'm going to bring a couple of up to make you aware of them, because it's going to come up later in your lives anyway, as long as you continue down this path. But I'm not going to have you memorize any of the exceptions. I just want you to know that they exist. Okay? And different periodic tables are going to give you slightly different electron configurations. Follow the electron configuration that the periodic table that you have in front of you provides you. Does that make any sense where I'm going? Use the periodic table that you have in front of you. All right, so anyway. Mainly, I wanted you guys to, for europium, is to get used to the idea of going to the Ds, then back to the representative area, so going from 4 to 3 to 4. Did you guys cover that pretty well? I gave you 2 opportunities on this. We went from 5 to 4 to 5. Okay. And then get you into the S. That's the first time you've ever been into the S also, right? And remember, did you notice something about the S? Well, remember we said that the transition elements are 1 less than the period number. So these are the 3Ds, these are the 4Ds, these are the 5Ds, right? What are you noticing about the Fs? They're 2 less than the period number, or the period number that they're in. Because remember, these fit in right here. We already talked about this, how the periodic table could be way over here. Okay, so these actually fit in right there. So the Fs are always 2 less than the energy level that they're associated with, or the period that they're associated with. How many of you had 6S? You had 2 here, and then you had 7 in the 4Fs, which is almost all of you, right? Because I saw the periodic tables you guys are using. That's fine. That's fine. So you guys had this. Which is good. But you'll never have that periodic table on a test or quiz. So, all right. I am done with orbital notation. Yes?
How many bands electrons is
Kind of depends. Well, I mean, if you want to go strictly valence electrons, what's the highest energy level? 2. But have you ever heard me ask you how many valence electrons iron has? Or cobalt? Or chromium? Where are these elements? They're in the transition metals, okay? And we're not there yet because I haven't talked to you guys about the charges on ions yet. That's coming up a little bit down the road yet. We'll go into why I never ask you that. Because they can form, the transition elements have a tendency to form more than one ion. The representative elements, though, form one ion. We'll get into that later. All right, on to the next type. I'm going to leave this up there for now because we're going to refer back to it, okay? But the next type is called, believe it or not, electron configuration notation. Don't let the long name make you nervous, because this is inversely proportional to the amount of space that these are going to require relative to the orbital notation. Orbital notation, very quick, very small title. Clearly we're only, what, halfway through the periodic? We're a little over halfway through the periodic table with europium. Wait, what did we say it was, 63? Yeah, we're a little over halfway through the periodic table with europium. Okay, let's go ahead and do, I'm just kidding. Hey, just out of curiosity though, what would we do after we got through the 4s? Then we come back to the 5Bs, then the 6Bs, and then the 7s. Okay, I just wanted to take you all the way through the periodic table. All right, anyway, so with the electron configuration notation, we are only going to look at the number of electrons in each type of orbital. Okay, so, for example, for nitrogen, how many electrons are in the 1s orbital? 2. So we write 1s2. That is not 1s squared. What's the next orbital that nitrogen has electrons in? A 2s. How many electrons are in it? A 2. So we put 2s2. And then the next orbital shape that nitrogen has electrons in is a 2p. And how many are in those? So we write 2p3. So we're not breaking it down into individual electrons in individual orbitals. We're just looking at orbital shapes at each energy level. So clearly, phosphorus would then be 1s2, 2s2. Now, for phosphorus, we had to go all the way through this, so we'd put 2p6, then 3s2, then 3p3.
I keep wanting to see you,
I know that.
but I won't.
I know that. Yeah, you will, once or twice.
I will.
All right, so this is a little bit shorter, isn't it?
Yes, I will.
All right, go ahead and do the next two. Does anyone notice the issue, though? Okay, there is an issue. We'll let you figure it out. Go ahead. Finish up the next. What were there? 2. Hi. You follow the order on the periodic table. So you go from the 4s to the 3D. Yep, yep. Did you guys get that for arsenic? Okay, just out of curiosity, you didn't get that? What did you get? Okay. Well, to get all the way through the D's, we have to have 10. Okay. Now, here, what we counted wrong. What were you counting? You were looking at this, weren't you? Did anyone just figure out the problem with doing this yet? Well, what are you referring to? This. Right? Is that what you're currently referring to? So this really isn't much shorter, is it? According so far. But it is. Let's finish up the europium just for fun. So, where am I? Oh. According to the periodic table that you guys were using, you had 4F7, is that right? Yeah.
When you say, so, if we base it off this one?
Yeah.
It would be...
Yeah, okay, if we base it off of that one, thank you, it would be 5D1 4F6.
Why do we only have one 5D?
Well, and again, this is an exception to,
I just want to make sure.
I understand, but this is number 57, right?
Mm-hmm.
What comes after 57?
58.
57 is in a D orbital.
Oh, okay. I got
58 is in an F orbital.
Okay.
Yep. I thought that was your question.
Yeah, and then I'd go back to D.
Yeah, and so then, yeah, if you get through the F's, now you go back to the D's and fill those out.
I just want to make sure.
Yep. Okay, so anyway, so now the question becomes, one, how am I going to do this without having all of this already available to me? And two, this isn't much longer or shorter, is it? Okay, it is shorter. I will show you another way here in a second, but let's talk about how am I going to get from to this without that. And this is why I've been leading you guys to this whole time. S orbital filling, P orbital filling, D orbital filling, F orbital filling. So let's do this together. Let's do like 2, and then I'll throw a couple more bones at you. Let's do the electron configuration notation for sulfur. Let's do it as a class. There's sulfur. How do I get to sulfur? Well, I go through 1s, 2, 2s2, 2p6, 3s2, 3p, 1, 2, 3, 4. Boom, done. You don't even need, you just need a periodic table. So can I throw you a couple of more elements to try on your own?
Yeah.
Here we go. All right, try those 4 real quick. Oh, you got so lucky. How did you know? You saw what I was doing, didn't you? I mean, I literally, it was coming your way in like a second. Alyssa's rethinking her decision to sit up front again. Things happen up here, don't they? I haven't hit you with anything yet, have I? No. It'll come. It'll happen. Pretty easy, isn't it? Oh, I see. That's why I did that. Right. That's why I gave you that one. All right. I'm hoping everyone got for oxygen 1s2, 2s2, 2p4. Just out of curiosity, how many valence electrons does oxygen have?
6.
Good. I still get, even in my AP class, I occasionally get kids say 4. All right, calcium, we should have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Yay? Great. Manganese, we should have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Hunky-dory? And then what do I have, germanium? Oh, here it is. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. How many valence electrons does your germanium have? 4. Once again, I can show you the different energy levels. Would you guys agree? Okay. You guys good with that? So between this and what the next thing I'm going to show you is where we're going to spend most of our electron configuration lives. This is helpful for some other reasons that we're going to get into a little bit later. But this is where we're going to spend most of our lives, except it gets better than this. What's this electron configuration? Or what element is that? Oh, time out. I didn't want to do that one. Time out. What element is that? Hold on. What element is that? And what element is that? And yeah, we'll leave those the same. What's this element? Neon. What's this element? What's this element? Also argon, isn't it? What do you know about the orbitals for argon and neon? Completely full, aren't they?
Yeah.
Let's not waste our time doing those. Let's just do the ones that matter, the valence electrons. So, remember I said there were 3.5 electron configurations I was going to show you? Well, the half one is based on this, except it's a shortcut. So we could write phosphorus just as easily as where we just put the previous noble gas in brackets and just do the valence electrons. For arsenic, it would be argon in brackets, 4s2, 3d10, 4p3. That's a little shorter, isn't it? And what about europium? Well, you're trying to figure that out, but watch this. Europium is here, right? So let's go back to the previous noble gas. Xenon. So you put xenon in brackets, which represents, I believe, the 5p6. Would you guys agree with that? 5p6, and just do the stuff after that, which would be 6s2, and depending on the periodic table you're looking at, either 5d1, 4f6, or 4f7. Now that's a thing, isn't it? So are you starting to, do you see how to do that? You find the element in question, you go back to the previous noble gas, put that in brackets, and then work your way forward from there. I don't know, I feel like 35 seconds.
I feel like it's close.
What time is it?
9:04.
I don't know what time we get out of here.
And we had 20 seconds.
Yeah.
Why is it only one of us on not
In where? Okay, watch this. We'll use this. Well, no. Let's use this. I like this better. He just asked me the same question about 5 minutes ago, but let's do it. So, here we go. We are, we're at barium.
Yeah.
Okay? Where's the lanthanum?
In the D, 5D.
5D.
Yeah.
57. 58's down here.
Okay.
What are these?
F.
F's.
Yeah, but why don't you put 2 electrons in there?
Well, because I can't.
Why?
Because that's only one electron.
Yeah, but can't 5D hold 2 electrons?
I understand that. It can hold them. It doesn't have to have them, though. So you follow the periodic... No.
Okay.
Follow the periodic table. So here we go. 5D1. 4F. Now, what if we went to hafnium?
Which one? Oh. That'd be D, wouldn't it?
Yes.
Okay.
Now you have your 5D2. Better now?
No.
And it was just, I did seventh grade.
This periodic... Whoa. I'll get it. Don't worry about it. This periodic table does the same thing. Okay? Because this element is actually right there.
Mm-hmm.
The F's don't start until here.